and the heat shield has been separated. This allows both the radar and the cameras to get their first look at the surface. Current velocity is 145 meters per second at an altitude of about 9.5 kilometers above the surface.
Yes, yes, yes.
Perseverance now has radar lock on the ground. Current velocity is about 100 meters per second, 6.6 kilometers of the surface. Perseverance is continuing to descend on the parachute. We are coming up on the initialization of terrain relative navigation and subsequently the priming of the landing engines. Our current velocity is about 90 meters per second at an altitude of 4.2 kilometers.
Almost there.
We have confirmation that the lander vision system has produced a valid solution and part of terrain relative navigation.
Yes.
We have priming of the landing engines. Current velocity is 83 meters per second at about 2.6 kilometers from the surface of Mars. We have confirmation that the back shell has separated. We are currently performing the divert maneuver. Current velocity is about 75 meters per second at an altitude of about a kilometer off the surface of Mars.
TRN Safety Bravo.
We have completed our terrain relative navigation. Current speed is about 30 meters per second, altitude of about 300 meters off the surface of Mars. We have started our constant velocity accordion, which means we are conducting the sky crane, about to conduct the sky crane maneuver.
We've lost direct to Earth tones.
As expected. As expected.
Sky crane maneuver has started. About 20 meters off the surface.
We're getting signals from MRO.
UHF is good.
Touchdown confirmed. Perseverance safely on the surface of Mars, ready to begin seeking the sands of past life. At this point, the descent stage has flown away to a safe distance. Perseverance is continuing to transmit direct through Mars Reconnaissance Orbiter to Earth.
Oh my God. Oh. Oh.
MRO reports they're still getting telemetry from the lander.
All right, all stations.
We got it.
Touchdown confirmed. We're going to wait for the images.
Wow.
This is so exciting. The team is beside themselves. It's so surreal. Stay tuned. We might get some pictures.
That'd be great.
So much has been riding on this.
Yeah, we just heard the news that Perseverance is alive on the surface of Mars.
It's not
Flight, we have seen the completion of EDL 3000. Copy activity. That is as expected.
MRO is still seeing a strong signal from the lander.
We have just heard the news that Perseverance is alive on the surface of Mars. Congratulations to the mission. And looks like we have some more news in. It looks like we're getting the first image. Here, take a look at the first image.
Flight, this is OL3. I have the target point on the map when you are ready.
We are ready, OL3. Go for it.
Flight, I'll be moving in, showing you the safe zone that we've landed in.
Just put the first image from Perseverance on the surface of Mars. Now, it comes from the engineering cameras, known as the hazard camera. This camera is mainly used to help the rover drive safely around Mars, and we will get higher resolution photos later in the day.
Look at that, right? You get the safe.
This is amazing.
Here's Andrew.
For Steve. Stand by for Steve.
You did. You led the team. You made it happen, man. Congratulations.
We just got our second image in. Our second image is in.
Okay, these we have a camera in the front and rear of the spacecraft. They're near the ground, so these are pretty close. You can see the wheels there, and they're a little dirty because we've got glass covers over these cameras. But we took these seconds after landing, so there's still dust in the air from our landing event. So this is happening. This happened just seconds ago, just arrived, and this is really amazing. And we even know where we landed. This is the most amazing thing. The vehicle has told us where it's landed because it figured it out. This is a sign. NASA works. NASA works. And when we put our arms together and our hands together and our brains together, we can succeed. This is what NASA does. This is what we can do as a country. On all of the problems we have, we need to work together to do these kinds of things and make success happen.
And joining us.
Alrighty, let's get everything back up here. There we go. I was kind of worried that wasn't going to happen before class started. I don't know, to me that's super cool. And kind of a nice, one of you posted the link to, so the eyes.nasa app. Hey, well, yeah, it's probably WebGL. Let's see what we got going on here. Ooh, it's minified. Look at that. Oh, God. Anything? Hey, look at that. It is WebGL. It's relevant to class. Where'd it go? There we go. Hey, there's our renderers. Haha. Swipe up for next phase, relevant. Yeah, that's cool. I don't know if any of you are watching the live stream at all, but the awkward interviews are the best. That's good stuff. Alrighty. Anybody getting a weird doubling of audio at all from me? I'm getting horrible feedback. Maybe not the greatest speakers. No. Oh, I mean, come on, you put a bunch of engineers together in a room and you expect them to be expect them to be perfect. That's good. These this headset from time to time does some very bizarre things. And at least it hasn't. Last semester was doing like a really popping and like horrible screeching in my ears, and I was kind of concerned of how awkward and dry. Oh yeah, it's so good. It's like watching a 1950s B movie or something. It's good stuff. All right, just getting everything together here. Okay, so let's see, class stuff. How did you all find the lab on Tuesday? I noticed, I think pretty much everybody got theirs in, if not everybody. I think I went through and graded it this morning. Level above C-SPAN. Oh, you mean C-SPAN's not exciting? C-SPAN is God, absolutely. Yeah, sorry, no Isaac stream there, Noah. Got usurped here. But yeah, so let's see, the homework that you have due next week. Hopefully you took a look at it. It's not, if you were able to do the lab, and everybody pretty much did, I think I only took off a couple of points if you made a small typo or something like that, but should not be too bad. But the assignment, come on, scroll please, thank you. February 25th. So you have basically a week from today to get that done. And please get it started sooner rather than later so that you can drop by and ask me questions if you have questions. Obviously, I'm throwing you in with animation and interaction before we fully go through the topic, but I wanted you to get going on that. Other points of note, 2 weeks from today, we'll have our midterm, and that will be lots of fun for all. I've got a study guide here in progress for you. I've got a couple more things I want to throw on there. But the way it's going to work, since we are online, is that I can't remember if I mentioned this or not, but I know people probably have forgotten by this point. I'll give you the entire day to take the exam, basically. So it's either going to be a Word document or it's going to be Blackboard questions. I haven't really settled on which one I like more at this point. I guess if any of you have any preferences, I'm still deciding, so your feedback is still accepted. But basically, you have the full day to take the exam. I will structure it like a normal exam I would give you in person. Short answer questions, couple of coding ones here and there. Should be zero surprises if you've been following along with class. And with all of you kind of, interacting during class, more or less, I'm not too concerned that people aren't paying attention, like I normally would with everybody dropping off to sleep in the back. But yeah, if you keep up with the content, you should be fine, honestly. And yeah, you will have the full day. So you would normally have the hour and 15 minutes to take the exam. I'm just going to open it at midnight and close it at midnight, basically. So you will have that full day. And should go without saying, don't cheat, don't plagiarize, don't copy and paste without attribution or distilling it. I'll give you more instructions on that as well. But treat it like a normal exam. So we will also do a review the Tuesday before that as well, in case you have questions. But anyway, oh, sorry, one other thing I want to talk about before I get into the material. Nobody has called me out on this yet, but we will have a small term project in this class too. Focus will be more after the midterm, after you've gotten some WebGL under your belt, and you can maybe decide if you want to go a WebGL or Unity or even Blender route for that. Since we are doing exams, it's not going to be like an entire semester's worth of effort. I would treat it kind of like a, 2 to 3 homework assignments worth of effort kind of a thing. So you have to give a little presentation on what you did. It should be something nifty, but it doesn't have to be like a fully blown game or fully developed game or, a incredible simulation environment. It can be like a proof of concept type of thing. I'll give you some more details on that in the coming days, but just start thinking about maybe what you might be interested in working on. I know some of you have OpenGL experience, DirectX experience, Unity experience, Godot experience. I don't care what language you use for it, just that it's going to be, kind of interesting and relevant to the class, obviously. Should be graphics focused. In my classes, people have done games before. They have done music visualizers. They've done simulations of human anatomy, all kinds of neat stuff. So your next assignment, I'll basically have a question where I'm asking you to start thinking about what you're actually going to be doing. So we'll get there as we go. Any open questions, or are we all good? Hopefully we're all good here. Let's click, make sure we are set. All right. So, animation and interaction. We have been talking about interaction in terms of the browser, right? We are going to use the browser's capabilities. We'll use all those nifty HTML buttons. We'll let the browser handle your mouse cursor, handle the keyboard. We don't have to do anything. The thing to keep in mind is that graphics are not always that easy, and you can even do some of the stuff that we're going to be talking about here in WebGL. But you have to kind of consider that this mouse cursor moving around the screen, for instance, and even this little green circle I've got around it, these are graphics being drawn to the screen. There is a buffer that has the mouse cursor. It is being sent to the screen along with everything else, right? And we see that it is on top of everything. It's not a trivial activity. It seems like it. We just take it for granted, but it is something we have to deal with. And what else do we care about? I'm going to kind of point at the camera here, but I'm trying to point at my cursor. There is an exact position that cursor can click, right? So it's going to be the tip of the little arrow. But what is that in terms of position on the screen? And what does that mean if our screen is different resolutions? Maybe it's different, different sizes, different orientations. Basically, we have a lot that we have to deal with in terms of interaction. And I guess historically, typically, browser axes are X and Y. Starts in the top left corner, 0, 0. And then we go positive this direction for X, positive this direction for Y. So if you look at any kind of standard game environments or standard graphics environments that are not WebGL, or I suppose OpenGL 2, where we have our axes in the middle here, this is where everything starts. Same with the canvas, honestly, in the web. If you're drawing to an HTML canvas, the origin is up here in the top corner. So we have to do some transformations in WebGL for that. Anyway, those are kind of the gotchas that we have here. Now, what do we see for a little bit of history here? We have a concept of what graphics are, obviously, but how do we interact with it? Well, I've got these, this kind of library with these sculptures here in the background. You are all looking at this. These are objects on the display, right? So this could be a 3D rendered bust. These could all be 3D renders where maybe they have properties attached to them. How do I interact with this thing? Do I touch it? Do I click it? Do I hit an arrow key and rotate it? What do we do? We have to have some way to understand how we are going to do something with this something else. So if we're going to click it, or we're going to touch it, or we're going to hover over it, or we're going to select it in some way. In graphics, we would call this picking. So to pick is literally a graphics term. Basically, you're going to do a transformation. Where is your mouse cursor? Is it intersecting with an object that you can interact with? So we're going to have to do a little bit of math for this kind of stuff. So let's say that we now have a notion that an object has been picked or selected. What does that mean? It just means that we have, say, a flag set, bust 0, active. Maybe we would then highlight it and pop up a bunch of information about this person. We could change the object, right? We could move it, we could rotate it, we could morph it. What do all of these terms mean? We are just transforming them with matrix math. Really, that's all there is to it here. So it's going to be up to you, the programmer, to figure that out, what you want to do with it. But the key with this concept here is that we need to know where the mouse is or the other object, right? And maybe it's not a mouse. Maybe it's a trackball, right? So if I move my mouse cursor up and down here, so I'm just kind of sliding it back and forth on my mouse pad, is the trackball that you're moving up and down going in the same direction, or is it reversed? How does your hardware know how to deal with that? Maybe you've got a tablet, joystick, this lovely space ball, which looks like an Apple IIe era joystick that I used to have. Maybe it's a light pen. So it's kind of like a light gun from the old Nintendo days where you have some object that can figure out where it is on the screen. Basically, with all of these, we have to figure out what we're touching and where in the screen, either physically or logically. And again, logically, because we might have to translate our coordinate systems from the top left corner to the center. Where are we at? Where are we touching? And fortunately, a lot of these devices, they're going to be handled by the hardware themselves. So when I talk about different devices like this, right? So if it's a mouse or a trackball, or maybe it's a joystick controlling your cursor, you as the developer couldn't care less, right? Because you're getting the input from the system. The operating system is telling you where the mouse is, or it's sending that data to, say, WebGL or Unity or whatever environment you're using, saying mouse cursor is here on the screen. Do with that information what you will. You don't have to handle that, but if you are doing low-level driver development, these are very real concerns. All of these are different pieces of hardware. They're going to talk to your system differently. But again, we're going to be looking at it from a bit of a higher level, so it's not as big of a deal for you all. So these devices that we have, they will have physical properties, right? You got your standard ones here, up, up, up. What about a VR handset or a VR headset? Or one of those, this is the Microsoft one where it tracks your hands, the HoloLens, where you put on the headset and it does hand tracking through basically a gimped Kinect sensor. These are all input devices that you have to deal with. Or you've got your iPad with your touch screen, tapping a keyboard. Everything is going to have some kind of a device, but at the end of the day, your system's going to register what the input is and tell you, handle this particular event. So what this means is that when you are developing graphics applications where you care about interaction, you have to know A, what events you're handling, and B, where either, I guess it depends, so what that information means. If it's a mouse cursor, what's the position? If it's a keyboard, what keys were pressed? If it is a touch screen, what is the gesture that you made? Right, this can all be translated to a logical property. And this will be handled by either your operating system or the API that you're using. Again, API being WebGL, OpenGL, SDL, Pygame, Unity, Godot, whatever it is you're using. They will have a nice, easy to kind of parse out method for that. Okay, so all these devices that we have, maybe it's a phone doing gyroscope data, or it's a mouse just clicking. You don't care as a developer, and that's kind of what I want to hammer into your heads right now. So we have physical properties, let the hardware handle that. Logical properties, this is what your API is telling you. Then you have the mode. So this is an important one for you as well, because you're going to set basically, are you waiting for an event to happen? So if I See, if I clicked my mouse, that would do stuff which I don't want to do. I guess we can, let's pop back here. If I click my mouse, event has happened. My browser has handled that event when I clicked the mouse, triggered a callback event, and because it knows we are in slides here, go to next slide. If you're making a game and I clicked something, that might be shoot laser or open inventory if you're hovering over the little backpack icon. Just kind of depends. So that's an event-driven input. You're waiting for the user to do something, or you're waiting for some event to happen. You could also do request-driven, where you're constantly polling for information. Has this thing happened yet? Yes? Okay, now do something. So these are kinds of the high-level things to consider for inputs, I suppose. Make sense so far? Everybody that's still awake and not looking at the Mars rover? I should stop saying are you still awake. That's kind of it's not a nice thing to say, I suppose. There's a lovely starter pack about teachers the other day. Made me feel bad about it. Well, I'm glad you're asleep. You know, the first time I had a student fall asleep in class, I honestly had no idea how to feel about it. Because either I had a very soothing voice and I put him to sleep, or the content was just so boring that he couldn't handle it anymore. Or he just had a rough day. But it's an interesting experience to put people to sleep. It was system administration, so it was probably all about Linux and probably permissions and user groups and the most exciting stuff in the world for students. Anyway, so we have our devices. You might have an incremental device where you're going to get direct information, right? So if I have a mouse cursor here and I'm moving it around, I could be returning direct inputs. I could also return incremental inputs. So if I move here, now let me show you this because this will be a good visual here. I could have a velocity in my mouse. So if I'm moving slowly, I've got a really small tail on this thing. If I move fast, look at that tail. Woo! What's happening here? So this is obviously a Google Slides thing, right? This is not anything that the browser is doing for me. But what's happening is that the interface here is calculating the velocity from one position to another, and then it's calculating how much of this tail to draw, and probably how quickly to fade it in and out, right? So we can kind of get either direct positional information, which is something that you probably would get with a mouse, honestly. You know, your cursor.x, cursor.y. But maybe you have a, you know, like a mouse wheel that scrolls, and you could have it go really fast or really slow. It just kind of depends. If you're going the velocity-based route, you can bring in a sensitivity to your inputs. Think of like one of those drawing tablet pens where depending on how hard you press, you have a bigger, thicker line that you're drawing in your paint program. Or if you got a nifty mouse like I've got, and this is going to, let me get off the screen here. Let's see, so I've got, it's a clicky mode, or a little ASMR there for you, or like a smooth scrolling mode. I can just flick this thing and it's gonna just keep going forever. So that would be a velocity. Oh wow, bragging about your mouse. Hey, yeah, let's see, I could go a sarcastic route with that, or I could go a snobbish route. No, this mouse I got, anytime I see it pop up on Woot, I pick up another one because I love this thing. It's a Logitech MX Master. I think it goes for 30 bucks when it's on sale. Worth every penny. One of my friends is really into the whole trackball thing, and I just cannot do that. He even does it for games, which makes him really weird. Anyway, yeah, seriously. So we have our direct inputs where we're getting our position. We have our incremental inputs where we care about velocity. Now let's talk about our logical inputs. So we have zero hardware with what you're seeing on the screen here, right? This is all parsed out from your programs that you're writing. So if you're writing something in C, C++, or Python, or you could extend this to Java or any language you want where you have input from the terminal or input from the user. So scanf or input or what is it, get line in Java? There is no keyboard that is directly sending information here, right? So you are tapping it in on your keys, right? So I'd put in 100.x or 100.5 for x or whatever with my keyboard, but I wouldn't need a keyboard for that. I could use a virtual keyboard. I could copy and paste characters from something else, right? The operating system is translating those keyboard commands and sending it to this program, and it's all being handled kind of logically behind the scenes. And if that's a little bit hand wavy, just keep in mind that we're not directly talking to the hardware with this thing. The computer is, right? You have a layer of abstraction here. But yeah, so the interesting thing, if it is a logical device, I forgot that I had animations happening here. You don't care what the device is to get input here. That's how you can tell if it is logical, because it could be anything. I could be using a joystick to kind of scroll through numbers to get this type of input. So we don't really know what that is. But what we do know is what the input is after it has been sent. And that, again, is going to be handled either through the operating system, the API, however you're talking to it here. And now we're going to kind of get into why I keep telling you how awesome the browser is for interaction, because we're actually going to start talking about how to handle these devices a little bit. So in the older APIs that we had, we could get graphical inputs in multiple ways. We could get a position, we could get a pick ID, where we'll talk about this when we start. We're not really going to go down the picking path too far because it's really, it's not obsolete, but it can be kind of annoying, and it's a little bit more advanced than we need to be right now. But let's say that I've got an object on my screen. So let's say each one of these characters are separate objects. You know, I am drawing out this G character, and if I clicked it, I could get the ID of this particular object here. Right, so I can actually, here would be an example. So I click this header. Now I see it highlighted. I have the ID of this object if I were to pick it, for instance. And obviously I'd have to code in there to handle all that fun stuff. But if I have the ID of an object, I can go in and work with it and maybe morph it, play around with its vertices or its fragments or whatever I have to do. So we could get a position, get an ID. If we're talking to the keyboard, we'll get characters. We could get positions. So if you have like a stroke where, again, you see like a trail like this, you're basically drawing vectors or something of that nature. Maybe we need an evaluator or a choice. It just kind of depends on your API what types of data you will be getting. In SDL, for instance, if you are getting, you can basically get a generic event where that event could be a keyboard press, it could be a keyboard release, it could be a mouse click, mouse release, mouse move. I'm pretty sure they have incorporated like gyro data in there as well. But it just depends on your API how you're getting your input effectively. All right, a little bit of history here. So this is going to look probably pretty painful, but I'm sure that those of you that have played with Linux, or maybe if you've looked under the hood in Mac, you've heard of X Windows. This is basically how we handle graphics in non-Windows systems. Effectively, what you've got going on is you need an X Windows server and an X Window client. Now, if you're doing like rendering, or you are doing graphical applications where you need multiple machines to handle this processing load, you might have a server dedicated to rendering graphics. And then all your workstations would... Ruh-roh. Thank you for that. Actually, I'm already not covering all that much here. I did add a little background to myself, though, to try and be a little bit less... There we go. No, the point is not necessary for you to open the slides right now anyway. That feedback's always fine. The slides are more important than my face anyway. But with this kind of a structure here, you have something that is handling the graphics rendering, and then you're basically sending them to a client. So if you've ever set up an X server, for instance, if you are running Python, like Pygame scripts on Windows, and you're using the Windows subsystem for Linux, you have to set up a X server because Windows needs a X server to draw to the screen. Let's see, I'm not going to be able to get on the screen. Just trying to figure out where I'm going with that demo there. Basically, you just need something to render the graphics, and then the client's going to be whatever computer is going to be showing it to you. Can be on the same machine. We can distribute it as you see here as well. So this is still kind of valid today. Tends to be on the same machine though. But be aware that if you are in the Linux world or you're in the Windows world and you need Linux, you probably either have or need to have a X server and an X client. I guess I can show you. So I use something called VCXserve when I have Python games that I need to run. Basically, it's a Windows application that provides an X server interface for Windows. And then if you go to say run, actually, well, let me show you, because otherwise I'm going to sit here blathering and nobody's going to know what the heck I'm talking about. Let's go to roguelikes, yeah, Pygame. All right, so if I run main, so this is a Pygame application, and then I fix the camera because I forgot to remove my demo. Video system not initialized. Right, so it doesn't know how to draw to my screen. I pop open this VCXserve, and oh, you know what? It's still not going to work because the audio doesn't work. Yeah, this is something else. Those of you that I was bugging about the Windows terminal, if you try to run a Pygame application from Windows subsystem for Linux, it does not like the audio yet. And I haven't figured out how to fix that short of going to PowerShell. But if I didn't have any audio here, it would be just fine. If I can try, sorry, not trying to waste your time here. Just got some various like little demos here. Club Sandwich, maybe? This was a nice little examples. Not too keen on this highlighting scheme here. Scenes, sure. Let's spell Python correctly. Yeah, I don't have it. All right, screw it. Basically, you need an X Windows system to draw, is kind of the takeaway, I suppose. And if you're in Windows subsystem for Linux, you need that as well. Anyway, so we have X Windows. Windows computers have their own setup for handling this, and my audio is doubling again. Lovely. I talked about input modes as well, and I'm not going to spend a lot of time here since I already kind of talked about it. But a mode is basically going to mean how are you handling inputs. Again, is it event-based where you're waiting for something? Typically, you'd handle it with a callback of some kind. In JavaScript, we had that, on key down event where basically we would handle the key code and we'd print it to the console, and then you moved your little triangle around. That was an event-based input. If we were going to a more of a request-based or a polling-based, we would have a for loop or a forever loop that would say, hey, have we received any input this loop? Yes, handle it. No, don't do anything. That's kind of the different side of how you handle user events type of a thing. Okay, so what do we see from a operating system perspective here, or kind of tying it in with your device and with your program? So let's say that we have some event that happens. So we're gonna trigger this process. Mouse click, keyboard press, whatever it is. The trigger is going to be sent to your API, basically. We're assuming we have a running application going here, talking to WebGL, talking to OpenGL or SDR or something like that. That API or operating system, depending on where we're looking at it, will measure that process. And this process is the event that happened. Now, if your program is requesting this input, right, we will say, hey, WebGL, what happened? Or hey, SDL, what has happened? What is in our event queue? For instance, an event queue would be all the events that have happened since the last time you looked. Or your process will send you a notification that this event happened, program triggers callback, we handle it separately. So let's see, hopefully that all makes sense. If not, it will become apparent. We are going to be mainly doing callback-based handling because we're in the JavaScript world. It's a lot easier to do callback-based programming. It's not that messy. It is a pretty decent way of handling it. If we were doing Unity, or when we get to Unity and we do interaction, it's going to be callback-based because you're going to basically link up your keyboard events with functions that get called, right? If you do it in Godot, it's the same thing. You define keys and then you just say what function gets called when you see this key press. Obviously, you can customize it too if you don't want to do that. But if we were doing something more procedural, right? If we are using SDL or OpenGL in say C or Java or something like that, we would have our forever loop for graphics where at the top of that loop, we see if the user has done anything. And again, if they have, like we'll have an if statement right after that. If if event.keys left arrow, if that's true, move the character left, right? We have code to handle that. And we did something similar in our program last time, but it was callback based. It's not event based. If we are good so far, do you usually want key press or key down? So those are the same thing. I'm going to guess you mean key down or key up. It's basically key press or key release or key down or key up. And that is a very, very good question because it depends, honestly. So think of it this way. Oh, you know what? It depends on the API. Yes, sorry about that. Sometimes it does mean that. You're right. Okay. Regardless, my answer is going to be the same. It depends what behavior you want to see. So if you are controlling a character, so let's say we got Sonic here, and you want him to keep moving across the screen to the right, you want to hold down that right arrow. That would be key down, for instance. So once I lift up the key, that event would happen if it was key up. So yeah, key press, you're right, actually, I think. Now I'm gonna have to look at some of the other languages to see if I'm getting confused. But yeah, there's both. Basically, it's do you want it to be repeated or do you want to have it happen one time? Because like in a lot of like shmup, like the bullet hell type games where you want to hold down the space key to, shoot your bullets out at all the enemies, and you have to like hammer that button to keep firing. It's really kind of annoying. I guess it's the Mario Party style of controller inputs. That'd be a key up because when you press it and you release it, that release is going to be what triggers it. You can't really get a nice repeating action from that happening. But it's more of a game design consideration, honestly. The events are going to be the same. It's still going to be right arrow, left arrow. It's just when is it firing. So it depends on your goals with your application, I suppose. Everything I've been talking about has been in terms of user input, though. Okay, keyboard, mouse, negative edge, button release actions, and fighting games, too. Yeah, absolutely. Going down the Smash Brothers Melee path here. Where they took all the fun stuff out of the button presses. Yes, so we have key presses, we have mouse clicks. That's all we've talked about really so far. We have a bunch of other events as well that we have to handle. So we have windows, right? If I resize this window, an event has happened. An event has happened. An event has happened. Okay? Every time I do something to the entire canvas, basically, we have events happening here. So if we resize it, if we expose it, if we iconify it, which basically means like turn it into an icon, so minimize it. These are events that you have to handle. Last time you were telling me about the DirectX buffering versus OpenGL buffering. That is an event type that you would have to handle. And if one of them forgets that texture, it can be problematic. That it is an event that you would have to handle. Great example here. You know, let me, just for funsies, let me pull up Binding of Isaac for a moment. Not because I want to game in class, though that is the goal at the end of the day. All right, so we have our game here, right? Event, 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 event. Imagine what we have to do to have this handled. Right, so we have a bunch of images in here, right, that are being scaled every single time I resize this thing. That is an event that we have to handle as graphics designers. And what the heck is this thing now? This is new. What is that? Are there secrets happening because they're dropping the new release? Hey, I have to look into that later. Anyway, a bit of an aside. Yeah, it's, I think they said they're just about done with the new version of Isaac. I'm very excited for that. Anyway, handle window events. You have to handle mouse events, obviously. What happens if you hit two buttons at the same time? What happens if you get one of those really cool MMO mice where there's like 30 buttons on it and they're all remappable? You have to handle those events. Everything else we've talked about here. You also have an idle state where nothing has happened, right? So this is kind of a neat thing to consider, where you can have things like this happen. Okay, your character has not moved in 1 minute. Fire off the edgy, cool, waiting for you to do something animation, right? Got your 90s angst right here wrapped up in Sonic. So these are all events. Okay, blank slide, best type. Now, how do we handle this input? We are going to process the event queue. Now, I don't have a lot of love for users. They always break your programs, which is why we have this lovely picture here of a common typical user. But this queue, and again, depends if you're doing callback or not. If it's callback, the queue is kind of handled automatically for you. Every single iteration of your program, something called an event queue will be filled up. To quote one of my undergraduate professors, he said that users are losers, and I have to agree with him. They just break everything. We develop programs for other developers, right? We don't care about other people. Just kidding. But they do break your programs. Hey, dude, check out this game I made. So he's a developer in that case. Anyway, so let's say that we have a loop of our application. You are absolutely spot on right there, by the way. I clicked my mouse 30 times somehow. Maybe I've got that amazing reaction time that you see. I have to handle all of those presses in between an event loop. I don't need users to break. I break them myself. Nice. Perfect. But what it means to handle the queue is basically to look and see what events have happened. Has a resize event happened? If so, do this. Has a mouse button been clicked? Do this. Has a mouse been moved? Do this. Do this, do this, do this. And when I say do this, all you're really doing is saying, if key press, do X. If mouse move, do X. It's not like a big complicated thing. And again, if we're going callback based, we're going to have separate functions to handle all of that as well. Hey, your game sucks. It's the feedback from any little tech demo I've ever made. Alrighty, so event queues hopefully make sense. Very procedural, straightforward. You have your forever loop for a game. The events must be handled as you get them. Again, we're in the JavaScript world. Everything's going to be more or less callback based for us. If we were not doing callback based, so let's take a quick look here at one of our programs. So this is CAD. This is in chapter 3. I don't think we're going to be getting to it today, but maybe we will. If we were to handle user input here procedurally, and by procedurally, I'm clipping off the charts here. Let me lower my volume a little bit. Sorry about that. If I was to handle user input, here we have our clear, so let's clear out our buffers. Then we're going to set our buffers with draw arrays, and we're going to send it to the GPU. And then we're going to recursively call animation frame. I would have something like this. Is going to be pseudocode, by the way. This is not correct in any way, shape, or form. Handle event queue. We do like if keys, key left, x minus minus, up, y plus plus, because we're going to be in the WebGL space. If we were in standard console land or standard canvas land, this would be y minus minus, again, because 0 would be up here, not right here. But this would be our event queue. If event.window resized, redraw, new x, new y, or something. That's, again, pseudocode. But this is us handling the event queue. And then once we're done, we would basically clear the queue saying we are now ready for new inputs or something like that. Instead, we have callback events. And this one, it's actually interesting because we're going to add an event listener for a mouse click event where as soon as you click your mouse button, this event is going to trigger. And you see a whole bunch of stuff in here that we'll talk about later in the set of slides, but this is your callback function for a mouse click. Or a mouse click in general for the, or not a, okay. This is for the mouse click. This is for the click button on here. So there's actually, let's see, where's it at? Where'd you go? Maybe not. Oh, it is for the click, okay. So we have that. It is, what was I thinking it was then? So confused. There's supposed to be a button here. Oh, I'm thinking of the other one. Sorry. Too many demos here. CAD 1. So this is what it's going to eventually look like. Yeah, okay. Anyway, we have callbacks here. And if we do a click, we're going to update the index. If we have a mouse down, we're going to update a bunch of buffers. We'll talk about that in a little bit. And one thing that I want to talk about too before we end, and talk a little bit about animating since there's multiple ways to handle that, but we'll get that at the end. Anyway, callback events. Hopefully make sense, regardless of how you handle it. You wait for the event to happen. And I guess just to kind of contextualize this, in case if you're not aware what a callback really is, all you're doing is setting a function pointer type of a thing, or you're telling the browser, hey, if you recognize an event happen, this is the function you call. So you just basically pass a function name or a whole function to some handler, right? You can do this in C++, you can do it in Java, you can do it in Python. Basically, just saying, if X happens, call this function. Yeah, it's possible in pretty much every language. You can even do it in C with function pointers. Lots of fun. Yeah. So in terms of the, let's see, nothing new here in terms of our view of our drawing surface, in terms of our interaction. Again, we have our browser, we have our canvas, we have our web server, hopefully behind the scenes. JavaScript engine is going to be the one talking to the browser to get your inputs. And this is where we're going to define our callback functions. Shouldn't be any callbacks in your shaders or anything like that, just in your JavaScript. I'm going to skip over the next couple of slides more or less because we've talked about this in great detail. But at this point, you should all be aware of how JavaScript is loaded in, right? We know that the browser loads the website, loads your JavaScript application, then it starts entering in the event loop. The event loop we haven't really talked about until today, but we know it goes load page, load JavaScript, shaders, talk to graphics card, draw. Kind of the reason why this is here, though, is that I wanted to really make sure that you were remembering to wait for everything to be loaded. And again, that's going to be your window.onload command here. Interestingly, while we're talking about this, for one, make sure you have it for all your applications, when you start writing your own stuff, not just copying from what I tell you to copy. But this is a callback function too. So the event that happens is that the browser signals that everything has loaded in your HTML file. So we have compiled our shaders, ideally at this point. We have loaded in all your libraries. We've created the body tags, the canvases, the divs, closed them off. Everything's loaded in memory. Then window.onload triggers. And what's that? In this case, it's this nice little JavaScript-y way of defining things. Equals function init. But I could just say window.onload init. And then, like down here, split it off into a separate function or something like that. Just this other way is kind of the more common way of handling it in JavaScript. But it is an event that happens, so just something to be aware of in that case. Everything makes sense more or less with respect to interaction. So we're going to start talking about animation a bit now. Yes? Question mark? Good. It's the correct answer. It all makes sense. And again, kind of one of the things, so let me refresh this here, and let's actually go to CAD 2 because this is a little bit more exciting. Which is why you have homework lab 2 burning on your back burner. So here is CAD 2 in chapter 3 of the GitHub page. So I'm going to draw a couple of polygons here, and I'm just clicking around, and then I'm going to click End Polygon. Now let's do click, change it to red, click, change to magenta, click, change to cyan, click, all done. So what's happening here is I'm drawing polygons on my WebGL canvas. I am not using buttons inside of here. I am not using the browser. Obviously down here I am, right? I'm clicking stuff and I'm just seeing now this is a little bit cut off. Me resize you a bit because clearly my screen share is not optimized. But got some colors. Let's do red, and then we'll call this a polygon. So there's some interesting things happening here, and we're going to talk about this a little bit later on. I am clicking. Every time I click in this canvas, what do you think is happening? I am taking the position of the mouse, and I am pushing it onto a list. Okay? So this is not a triangle. This is not a square. This is a legit polygon with no defined number of vertices. So the way this thing is working is that every time I do a mouse click, figure out exactly where the position of that mouse cursor is with respect to this drawing area, push that onto an array or a list, and then also push down whatever color is currently selected. Right, so here we have a list that are available to us, and obviously we translate that to our RGB values. And then later on, when we go to draw, which happens when we click End Polygon, draw whatever is in the buffers. Right, it could be a triangle, so we could do our standard triangle, triangle, triangle. We can do a square with differently defined edges. I drew it backwards so we get this kind of odd shape. The trick here is that obviously these we could make available inside the drawing area. Would be a lot of extra effort, but we have this interaction that we need to now figure out. So that's going to be the tricky part for us all. and why I kind of say that handling the canvas is a lot more annoying than handling interactive elements like this. Just kind of give you a heads up of where we're going with that. Let me bop ahead, way ahead. Where are you at? Oh, it's way down. We have some math to do, basically, if we want to figure out where the mouse cursor is. So that's where we're getting to with this stuff. Back. Because we are going to do a little animation here. But let's talk about animation. You all did this on Tuesday, which was great. You got started with it. You got a feel for it, and then you realized that it's not going to be that bad, honestly. So let's get a rotating square. Hey, it's doing it again. It must only be when I'm streaming that it does this thing. Back here. Okay, so if I want to animate something, that means changing its vertices, basically, right? Or if we're changing its color, we could update its fragment color as well, from frame to frame. Now, how would we do what I'm showing you here? The weird steps notwithstanding. Well, we could feed in mathematical functions to our vertices, and we have a bunch of well-known trigonometric functions and identities and formulas that I'm not going to expect you to remember, don't worry. But if we want to move, say, around a square, we could send in some sines and cosines, absolutely. How do we animate it? We update the positions and we re-render. That's all it really is here. So I've got this rotating square 1. And again, I have shown this to you before, right? We jumped into this 2 times ago. We are actually doing some vertex updating now. We are not simply passing through our vertices. We're actually letting the shader do some math for us. So figure out the sine, figure out the cosine. What do we see here when we look at the shader? It's kind of generic. So if you're looking at this here, and let me go back and forth to the slide once or twice. So this one is negative sine theta, cosine theta, sine theta, sine negative cosine, negative sine. So these vertices are all governed by different formulas. Yet our shader is doing something kind of generic here. Right? So basically what we've got going on is that we have a little bit of magic math happening where the x is going to be negative, y is going to be positive. So we're basically doing this guy here. Then our y is times c. Yeah. All right, just kind of going back and forth here, getting lost in my train of thought. Yeah. Getting elderly moment. They happen the older you get, don't worry. Basically, we're going to be looking at this one here, more or less. So negative sine, the x is the negative sine times the y plus the cosine times the x. The y is then the sine times the x plus the cosine times the y, which is basically what we're getting at out of here. You're too young for that to happen. Anyway, the key takeaway here is that the shader is handling the sine and cosine, which if you are doing this on the CPU, you probably would want like a lookup table to really speed things up. But we don't want to have that. We just are going to let the shader handle it. Again, shader's good at trig, shader's good at matrix math. So we have that. And we're updating theta every single iteration of our loop. Right, so if you remember, theta is the angle that we're passing in. And in this case, it's just a incremented value here. So we're going to update that every render loop, pass it into the shader. The shader is going to do the calculation, set the vertices. There we go. Now, there are 2 ways that we could handle this. So the simple way, and I've got this in quotes here, you are not going to see this in any of the examples. This is in the application. So this is inside of basically the render. Well, it's going to be, yeah, so it's calling render itself. There's no recursion here, right? So for theta equals 0, theta is less than some max, theta plus equals some offset. So this would be like 0.1 based on what we currently have. Calculate your vertices out, create your vector 2. Here's your sine, here's your cosine. We're using the JavaScript libraries. Not the most ideal way to do things. And why is that? Again, it's because you're making the CPU, not the GPU, do this sine and cosine calculation. And even worse, we're doing it 4 times each, which is really bad. So this is the simple way. It's probably the most logical way to do it. If you're just starting out, just dump it in application, right? No, we let the shader do the sine and cosine. You also see this called a gl.buffer subdata. We will get into this one. Basically, we have a big buffer of information that we're sending. Buffer subdata is working with a little chunk of that buffer. So it's like a sub buffer, basically. But this is not a good way to handle it. Don't do this. What was wrong with that? It is CPU bound. So I already answered the question for you all there. The better way is to use the GPU. So what are the takeaways that we can get out of this? Obviously, the shader needs to know where the vertices are, where they're starting. We're going to create a uniform variable where, if you remember from that, it's basically how we're going to link a variable that is not going to change during that iteration from the application to the shader. We'll do the computation on the shader, meaning the graphics card is handling it, and then we'll do our rendering as usual, recursively. So this would be the render function. Honestly, this is what I just showed you in the code. Again, here we've got rotating square. Theta loc equals get uniform location. Notice you all answered this, I'm pretty sure, for the, I think it was in the last homework I asked you about this. I'm thinking the exam review, I'm not sure. But basically we're linking that variable up here. So theta loc, theta, link them together. Life should be good. Again, slight bit of extra abstraction here where we have the variable that is linked and then the other variable, and then we basically say transmit that to the shader. Shader consumes it, does the calculation, thing rotates, life is good. Let's see, so yeah, this is what I already talked about. All right, so let's talk about 2 more things, and then, actually not, I do have this here. So yeah, we'll do buffering and buffer swapping and interval timers and all this, and then we'll probably end it for today. Let's see, anybody figure out what W is yet? I made you look it up, so it's a fun one. The spoiler is that it's not always going to be 1.0 for us when we start moving into the 3D space. All right, a couple more things here. So far, we've talked about interaction, we've talked about animating, and again, animating is just the process of making small incremental changes and updating your display. Nothing super magical there. But there is one thing that happens behind the scenes for us, and that is something called buffering. And for our browser, and honestly a lot of APIs, there is something called double buffering that happens. So what occurs, and this will vary depending on which API you use. In SDL and OpenGL, you actually have to trigger this manually. The browser's doing it automatically for you. But when you render something, it is actually being rendered to a hidden display. Okay? So when we call gl.drawArrays, it's rendering to an invisible screen. It's being basically calculated out and everything's going to a buffer somewhere else. Since we have 2 buffers, we'll call them the front and the back buffer. The front buffer is what is being displayed. The back buffer is what we're rendering the data to. So when you call draw arrays, it goes to the back buffer. We have to do a buffer flip, and then the front buffer will be shown. So basically we're going to take the front and the back and we're going to swap them. And then we're going to draw to the back again and swap and draw and swap and draw and swap. This is one way to handle rendering. If you, basically it's just one of the ways that our APIs would handle that. And the nice thing with the browser is that this is automatically happening when we call draw arrays. It's one of the last thing that happens. So if you call request anim frame or the interval timer, that's actually the call that's going to trigger the buffer swap. Draw arrays again sends it to the back buffer. Request anim frame triggers the buffer flip. If you are in SDL, which is the 2D API, or OpenGL, I don't remember what the OpenGL call is, but it was, I think it was displayed at flip, if I recall correctly. I'd have to look that one up. But keep that in mind. Another thing that you might run into, which is maybe not confusing, but something to be aware of, is that you also have the notion of a browser refresh rate. So basically, browsers will typically refresh your display at 60 Hertz, try to match your common monitor displays so that you don't get like weird artifacts happening, things of that nature. Keep in mind, this is not the swap occurring. So when you look into browser refresh or browser flip, just be aware that if you look into this like 60 Hertz range type of thing, it's not doing that flip. You have to trigger it with one of these two JavaScript calls here. So double buffering hopefully makes sense. I hope anyway. It's one of those things where if you are doing a more hands-on language like OpenGL or SDL or something of that nature, you probably have seen this or experienced it. In WebGL, it's going to happen magically by simply animating. And in Unity and Godot and other frameworks, you're not going to worry about that whatsoever. And it will handle that for you. Unless you need fine-grained control, obviously. All right, last things to get into. So the timers. After everybody dropped off of the lab, except for a couple of you, we started talking about frame rates and how to set that. And one thing to consider is that this is an interesting topic in terms of JavaScript. So I have been showing you request animation frame, right? So that is our way of triggering an animation. We also have set timeout, which render, say, 100 milliseconds. We also have set interval, which are called similarly. So let me do set timeout. And I've got a couple of links here that I'll pop into the chat as well. So let me refresh you. So this looks pretty good. So this is with set timeout. Let's do set interval. Oh, that's interesting. I think we need this. Wow. That is not doing what I thought it was going to do. So do you remember way back when I said, oh, that's neat. What if I make this 1,000? What are you doing? God, it wouldn't be a demo in class if it didn't go horribly wrong. What the hell is happening? Oh, where's my set interval? Oh, is that what's happening? Am I recursively calling it in here? That might be it. Let me... That's probably why my response is going to dog shit too. Thank you. Thank you. Angry Carrot. Let's make this a little bit smaller. So I did this before and it wasn't bad. Thank you. That was going to drive me nuts. Wouldn't be a class if I didn't screw something up. Anyway, the key is that we have 3 ways that we can recursively call render. We can use set interval, we can do set timeout, we can do request animation frame by itself. If you start poking around on Stack Overflow, there are some differing opinions out there. Basically, the takeaway is that request animation frame is the best way to handle animation, and then you have to manage the frame rate yourself. Basically, you get better animation that way, and there are some JS fiddles out there which show you how to handle that, but then you start getting into managing time and calculating out tick rates and things of that nature. But we also don't see it speeding up or slowing down as I move my mouse around because my computer is too overtaxed. So and I guess what happened here, if you weren't paying attention, I was calling set interval recursively without any care in the world that I was continually spawning off render calls inside a render call, exponentially increasing its size. So thank you for that. But if we want to get to a particular frame rate, let's say we want 24 frames per second, we'd say do 1000 divided by the frames per second is the simple way of doing that. So let's say on 60 frames per second, we do something like this. Look at that buttery smooth 60 frames per second. But if you do ignore that, which is fine, it depends on your application. So if you skip the interval, or you just call request animation frame without any extra effort, it will try to go as fast as it possibly can, and you will be left to the mercy of the browser. Again, with the browser, it's doing more than just serving your application. There is a lot of stuff that the browser has to do as well as serve your WebGL canvas. It's handling input, it's talking to the browser, or it's talking to the computer. It's a hefty application. Whereas a raw OpenGL program doesn't have all that extra cruft to deal with, honestly. But some things to keep in mind. And again, request anim frame, yeah, okay. So what we'll do, we'll leave off here. Next time we'll start talking about collision detection a little bit. Anybody have any leftover questions from today? Look at that baby purr, ready to bonk triangles. Hey, you could add an unclick event, figure out where your mouse is, and then bonk them. That'd be a fun little project. All right, well, if that is it, I hope you all have a wonderful weekend. I will see you Tuesday. Please feel free to drop me a line. That would actually be kind of cool. So if you have a object and you click it, and then you split that object, is that a problem with the Cloud web page? When I made changes in the terminal index.html, they don't appear on the page. Is this a browser cache issue? I wouldn't expect it to be. Are you opening that as a super user? Like, is it actually saving? Yep. Have a good time. See ya. Do you know what I mean, though? Like, if you save it, does it actually say it's saved? Yes. Okay. I wouldn't expect it to be a cache issue. So, is it possible that you're updating the wrong file or that it's in your home directory rather than the web server directory? I guess without seeing it, I can only guess, but it should be pretty much instantaneous. Like if I were to go to mine here, Technically, class is over, so you don't have to stick around if you don't need to. But try and debug this really quickly here for you. I guess if you want, Smeagolicious, if you want to hop over to Discord, I could try to take a look at it if you want to do a screen share or something. Sure. Okay. Alrighty, well, I will end the stream otherwise, so hope you all had a good time. See you Tuesday. Bye-bye.